All right, well, hello everyone and welcome to the second workshop in the Python workshop series. I'm Jeffrey.
And I'm your co-host, Marlene Salazar.
And today we're going to be going over functions and returning values, basic programming logic and if-else statements. Now, if this is your first workshop that you've gone to, don't worry if you're missing out on anything like the introductory stuff. I posted a link in the chat for the first workshop, a video for the first workshop that you can go to after this workshop, so you can learn the first syntax, the initial syntax. So, Marlene, if you could.
So previously in the last workshop, we did learn about why we were using Python 3 and Google Colab. We also did how to recognize code using comments, making simple input and output functions, some of the basic data types that can be assigned to variables, and basic PEMDAS related math operators. And like Jeffrey said, don't worry if this is your first time. We do suggest you watch the first one just so you guys can be familiarized with all of these concepts. But for this workshop, we will be going into functions for our first topic. So functions is a set of statements put together that do a specific task. So it's basically like a code of block or just a function name. So they usually take an input or set of inputs to produce an output. And they're primarily used for tasks done multiple times in a program. So some examples that we covered last workshop was the print function and the input function. So here are some pictures of like some basic ones. And then, in this next slide, we'll go more into these. So defining a function. So functions are created and defined as follows. So here's a structure on how to define a function. You have to use the keyword def, which is define. And then the function here is the name of the function. And then it can be anything as long as it follows the variable naming conventions as we discussed in our first workshop. And you must always define your function and the parameters before adding statements into the function. So here, in the picture you can see a basic function. It says def, speed convert, and then within the parentheses, your condition.
Okay, should be good now. Okay, so just to make sure, whenever you're defining a function, they're defined in this specific order. Define def is a keyword to start the function definition. Function name is the same, well, it's the name you want to give your function. It can be anything as long as it follows variable naming rules. The main ones being it can start with like a letter or an underscore. It can have letters, underscores, and numbers. It can have uppercase and lowercase, but it cannot start with a number or a special character or something related to that. So then you have the parameters after the function name. So parameters, or the arguments, the inputs, they're the inputs that you give to a function. These variables will be used within the function. Conversely, you can decide to leave this area blank. And then all of them end with a colon. And then in Google Colab, whenever you go after this, it'll automatically indent for the statements that you want to put in the function. So here are some examples of correct function definitions. Here you have define motor speed with the parameters volt val and reset on. So it follows the naming conventions with the variables starting with the lowercase v, lowercase r. Function name follows the naming conventions also, and then ends with a colon. And the same can be said for this one, even though it only has one parameter. It still follows the naming conventions. And then for this one, there are no parameters, so there are really no inputs or direct inputs into this function. and then the function name follows. Now, incorrect function definitions, like this one, so the parameters are correct with starting with lowercase letters, there are two of them, but the function name starts with a number, which you can't do. Same goes for this one, where it starts with a special character exclamation point, and in fact, the exclamation point cannot be in a function name. It's a special character. And then for this one, the parameters are incorrect. So you can't have a number first in your parameter names or variable names. And yeah. Now continuing on.
So after defining the function, you must indent the code within the function, either using tabs or spaces. So I know like if you're using some Python IDEs, indenting 4 spaces tells Python what lines of code are in that block. But in Google Colab, it is 2 spaces, and it also does it automatically when you tab it over. And then when you're ending, like Jeffrey said, when you're ending this function, you either return, you end it with a return statement or no indentation. So what happens if it isn't indented is that you will most likely create a Python error. Python expects you to indent something after you end a line with it with a colon.
To elaborate, so after your function definition, you can start adding statements within the function directly below with an indent. So here's the function definition with the order stated before. And then right below it, you have 2 indented lines. This one, what is it? Whenever you run this function, anything that's indented directly below it will run. So whenever you run this function, it'll then start here into this indented line and then print input string is, and then whatever input string you declared as earlier. And then after that, since this is also indented, it'll go on to the next line and then the next line until it's not indented. So an example of a not indented line and it not being in the function is example 2. So whenever you have this function definition, right? And then you have the indented statement right below it. That means it'll run whenever you run print function. Now this one, since it's outside of print function, it'll still, it will not print as a line of print function. And now you can end functions with either just not indenting as above, and you can also end it with the statement return. I mean, return basically means the end of a statement, and you can also return a value, but we'll go into that later.
Okay, so using functions. So after a function declaration, the function will not be used unless you call it. So just like the print function and the input functions, a function is called and either does something on its own or it stores a value to something. So you call a function anywhere you may need it. And just like below, we have here the function math thing. Up here, it's declared and defined. And then at the bottom of the code here, variable equals 1, variable 2 equals 2, we call that function math thing, and it will operate that function at the top.
Yeah, as Marlene said, when you declare a function, it won't automatically be run. Instead, you'll have to call the function somewhere else in your code. So you can call it on its own, just like in the non-indented line. So here we have defined print function, and then it'll run print output should be 2 whenever it's run. Now, if you just have these 2 alone, the print function will not be executed. Like say if you decided to comment out this, output should be 2 will not execute because this function is not called. Now, whenever you call it, the function will run, and this print statement will run. Now, you can also call a function within another function. So here we have 2 function definitions. We have print function with the parameter var. So it'll print out whatever this value here, var, whenever it's called, it'll print it out here. Output should be, and then whatever the value is. So this next function definition, input print, so it starts out with x equals int input, cast the input into an integer. And then this is where you would have a user enter any number. And then it then calls print function with this user inputted x. So whenever run that, then this will run with var being x, or let's just say 5, right? And then this will print out output should be 5. Now, this will all only execute if you run this function right here, input print. So whenever you run this, it'll run input print, go through here, call print function, and then print here.
Yes. So, oh, and also remember, you guys can follow along with the Google Colab and like write these as we go. We taught you guys how to do that in the first workshop. But back to the PowerPoint. So other function notes. Variables are declared within a function and cannot be used anywhere else. So the variables that you use within that function block must just be used for that function block. So if we declare a variable named arm speed within the function arm controlled func, then arm speed can only be used within the arm control function. And then functions can return a value to a variable. So at the end, how Jeffrey showed you that we had the keyword return, it returns a variable using the function. So example, if we declare a variable as count val within the function clock, we can have a clock return, can have the function clock return a value the same as count value. And then you can always call a function within other functions. And if you're wondering if there's a limit to the number of arguments a function can have, it depends on the version of Python that you use and the computer that you're on. But it is fairly large. The practical limit, though, is about like 5 arguments before the function becomes like annoying to use.
All right. So going into variables declared without a function, variables declared within a function cannot be used outside of it. So say if you have this function bot direction and then you have x as an input. Let's say you input, I'll just change it here. You input 6. And then you also have a declaration x equals 5 outside of the definition, the bot direction definition. So these 2 x's will be different. If you were to use x and say a print statement, right, print x, this x equals 5, will be printed over this x equals 6. Now this x equals 6, whenever you're in the function, say if you print it here, this will take precedence here, but whenever you print x here, this one will print. And then functions can also return a value to a variable. So example, we have this distance function that executes, it'll declare a variable distance equals 10, and then distance equals distance times 5. The output should, or the new distance should be 50. So whenever you return distance within, outside of this function, it'll return 50. So whenever you call distance function and to change x, it'll turn, whenever you run this, it'll turn into 50. X will become 50. And then you can have as many parameters as you want in a function, but more than 5, usually excessive. Most, from what I've seen, is usually around 4, 3. You don't need to use all parameters in your definition. Like, say you have this function that it's called alphabet. It goes through all letters of the alphabet, but let's say you only use A, B, and C. That's completely fine. And also the amount of variables in the parameters, it's just too much. You won't be using all of them usually. Now, to programming logic.
Okay, so the programming logic. In Python, we have the following terms or characters and phrases for determining if something is true or false. So logic on a computer is all about seeing if some combination of these characters and some variables is true at that point in the program. So we use a true and false statement variables. So like if it's true, if the variable exists. If it's false, the variable doesn't exist and it's not true. And we also have and, or, and not. All inputs must be true to output a true, and or just one input must be true for the output to be true, and a not is whatever statement you have will be negated. It'll be the opposite.
Right. Demonstrate that one. So we already went through which each of these statements do. True statement or variable is true. False, the statement or variable is false. And between multiple inputs, all of them have to be true to output true. It can be as many inputs as you want, but all of them have to be true. The same goes for or, but only one of them has to be true to return a true. And the not, whatever statement you have will be turned opposite. So if you had like x equals true, and y equals false. This is what we'll be using for this example. So whenever you do x and y, you would, from this statement, return false, because x is true, y is false, and since just one of them is false, the entire statement becomes false. Now, it's different whenever you do x or y, since one of them, x, is true, so then it will return true. Now, if you negate x or not x, this turns x into a false. So then it turns into false or false, and the statement will return false.
Okay, so another thing you also must know is comparative operators, and here we have a list of them. We have the if two values are the same, condition is true, and the two equal signs are totally different from just one equal sign. I don't know if you guys remember, but in the first workshop, we went over the one equal sign, and that one is just setting the right variable to the left variable, but here we're actually comparing them from the left to the right. And if they're not the same, the condition is true. You use an exclamation point and then an equal sign. And then the other ones, most of you already know it, the greater than, the less than, and then if the left greater than or equal to right. And then the last one, if the left is less than or equal to the right, the condition is true.
More into that, we already went through these. Values are the same, returns true. If the values are the same, they return false. And then you compare these. Pretty much all of these are going to return either true or false. So in this further example, we have x equals 5 and y equals 6. So whenever you use the double equals for x equals 5 or is the same as 5, it checks if x is the same as 5, which it is. So this will return true. Now, whenever you do x is the same as 5, whenever it checks it, it will return false because x or 5 is not the same as y or 6. Now, if you did exclamation equals, that means not equals to. So if you were to check this statement, x is not equals to y, then it'll return true, since 5 is not equal to 6. Now, for a comparator, another one, if you tried x is greater than y, then it will return false because x5 is not greater than 6 or y.
Okay, so the truth table. So do some Boolean practice, and Boolean logic is used everywhere in programming. So they're essential fundamental parts of computation. And so after the workshop, I do recommend you to familiarize yourselves with these truth tables. They will help you understand programming logic more extensively. Yeah, so you can always go back to our presentation, look at these truth tables, try to really understand these truth tables. And then the if statement. So an if statement, it tells your script, if this Boolean expression is true, then run your code under it, otherwise skip it. And so when an if statement is true, the line block will execute below it, and then when it's false, it will skip over to the next statement. So statements to be used under an if statement must be indented like statements under a function, because it is a function, so it works the same. And then the basic usage here, we have an example, if, and then parentheses condition. And what we mean by condition is what we just showed you, all the Boolean logics, like 5 is greater than 2 and 2 less than 5.
Okay, so for this demonstration, we're going to be doing a lot of 5 and 2. So if statements are for using logic in a program. They are structured as follows. If, and then you have your Boolean condition, which will return either true or false. If statements check if a condition is true. If it does, the statements below the if statements execute. So whenever you do if 5 is greater than 2, which it is true, this if statement will execute, and all lines indented below it, just like the function, will execute. So it'll print out 5 is greater than 2 and 2 is less than 5. Now, if this statement right here, if a statement is false, the below if statement will not, or the statements below the if statement will not execute. So since you do if 5 is less than 2, which it's not, it returns false, so none of these print statements will execute. Just like a function, statements to be executed after an if statement must be indented. So if you were to do this if statement, if 1 is greater than 2, which it's not, this will not execute since this is false, but this will still execute since it's not indented and underneath the if statement. And then you can also nest if statements within each other. So let's say you have if 5 is greater than 2. That'll return true. So if you're to go into the next line for the if statement below, there's another if statement. So since if true, it'll print out this if statement below this one. You can also have a block of if statements one after the other. So you can do if 5 is greater than 2, that will return true. So this prints out. If 4 is greater than 2, then it goes to this line and it prints out. If 3 is greater than 2, that's true. Then it executes this one. But if you only want one of these statements to process, you have to use else if statements.
So an else if statements. So in the previous if statements don't execute, you can use the else if statements. Or in Python, it is elif, and here under the fourth bullet, the basic usage is elif and then the condition. So basically, if the first portion doesn't work, then it checks the next option. And then if you want to add more options, you can just add more elif blocks for each possible choice. And then if the condition is true, it will execute the indented code.
Okay, else if statements are elif statements in Python are used if previous statements don't execute. Once an else if statement executes, any following else if or else statements won't execute. So you use it just like a regular if statement with, instead of if, you have elif, and then you have your Boolean condition and colon. So for these following examples, you're going to have x equals 5 and y equals 6. Let me change these. Okay, so if you're using only ifs, so if you just walking through this, you have this first statement. X is the same as y, which it isn't, so this one doesn't execute. Then it goes on to the next one, and it goes x is greater than or equal to y, which it isn't. 5 is not greater than or equal to y, so this doesn't execute. X is less than or equal to y. This is true, so it executes this statement. But if you don't have an elif statement, this next statement, this next if statement will still execute. So if x is not equal to y, which it isn't, this will still print. Now, if you're using elifs, going back to pretty much this similar block, these two won't execute. This one won't execute because 5 is not equal to 6. This won't execute because 5 is not greater than or equal to y. But this one does execute since 5 is less than or equal to 6. This prints. But then since this has been executed in this block right here, everything after the executed elif or if statement will not happen. So this will not execute.
Okay, so the else statements, if the set of if and elif statements don't execute, they're false, then you can have an else statement to handle the exceptions. It's kind of like a default. So like if none work, it will execute the else, which is used as default. And then what happens if there's multiple elif blocks, if they're true, then Python starts at the top and it runs the first block that is true. So it will run only the first one. But yeah, else is just like the default.
Yeah, else statements are used to encompass exceptions to previous if and elif statements. If the conditions are not met in all previous if and elif statements, the else statement executes. So going through this, if 5 is less than 2, which this is not true, then it skips over this line. Elif 5 is the same as 2, it is not true, so this doesn't execute. This else statement will execute because these previous if and elif statements did not execute. So then it'll print 5 is something to 2. And yeah, that's the main information that we have to give to you today. So we have a little challenge for y'all to do in the next 5 minutes, I guess. We want y'all to create a calculator that takes in 2 user inputted integers and an operand, or just a math operator, and performs the desired calculation between the integers.